Hi, Zachary Ring from Thea Enterprises, here with another Lutron how-to video. In today's video, we'll be talking about single variable programming. We call this single variable programming because we're checking the state of one variable or one condition at a time. If you only need to check one condition when performing an input action, like a button press, it may be advantageous to use single variable programming instead of conditional programming. However, variables are frequently used in conjunction with conditional statements and other advanced programming examples, which we'll cover in later videos. In today's video, I'll show you how to create a time of day variable that contains three states: day, night, and late night. Then I'll show you how to create three time clock events that flip or change the state of that variable. Lastly, I'll show you how to apply single variable programming to a keypad button, and then we can perform three different output actions depending on which state the variable is in when the button is pressed. To get started, use the Program drop-down menu to navigate to Define Variables. Click Add Variable, found in the lower left-hand corner of the screen. Then name your variable. One thing I like about variables is that they're global and they can be referenced anywhere throughout the project. Something like time of day is something that you'd want to check on multiple keypad buttons, sensors, etc. By default, you'll have two variable states to work with, but you can add more simply by clicking Add State. We'll use three states in our example. I'm going to make the default state our day state. Note, the system will set all variables back to the default state after performing a transfer. If you need to change this, you can simply use the terminal function to set the variable state manually. If you know the time period that each state will cover, go ahead and add that to the name of your variable state, just because that will help you keep track of things when programming. 5 a.m. to sunset, sunset to 11:30 p.m., and late night, 11:30 p.m. to 5 a.m. These are obviously just suggestions, and you can have as many states as you'd like. Next, we'll navigate to Program Time Clocks. I suggest adding a separate time clock for your time of day variable events. Name the time clock accordingly. You'll want to make sure that this option is selected, Run Events Missed During Power Outage, because we're going to use three events to flip the state of the variable, and if the power was out when one of these events was supposed to run, we'd want to make sure that the system caught up after power was restored so that our system ends up in the correct state. We'll name this first one Day, and this event will occur at 5 a.m. every day of the week. And it's going to flip our state to our day state. We'll do the same thing for our next two events. So night at sunset, we'll flip this to the night state. And of course we have late night at 11:30 p.m. And let's just double check this here. 5 a.m. flips to day, sunset flips to night, and at 11:30 p.m. every day of the week, it'll change this to our late night state. Now we'll navigate to Program Devices so that we can apply this logic to a keypad button. You can apply this to any keypad button in your system, but I'm going to apply it to the bathroom entry keypad. I'll start by changing my program type from normal to single variable, and I'll select the time of day variable. Note, any existing programming that you have will be removed. Now you'll see the three states that we programmed showing up as tabs. What I like about single variable programming is that everything underneath this tab should look familiar. You have your button type drop-down, LED logic, and all the press on and press off actions that you'd expect to see. What I'm going to do is program the bathroom downlights to turn on to 3 different light levels depending on what time of the day the button is pressed. So during the day, I'll have them come on to 100%. At night, I want to make sure I change this to toggle so that the functionality matches. And here we'll choose 75%. And if I walk into the bathroom in the middle of the night after my eyes have already adjusted, I want the lights to come on to a more dim light level. So I'll do 35%. Just like with conditional programming, we are introducing some extra risk when using single variable programming. For instance, if I forgot to program an action on this tab, this button would not be functional between the hours of sunset and 11:30 p.m. So it's very important to double check your work and also to test your system thoroughly using the terminal function. I also think it's important to give the end user a way to quickly turn on the lights to 100% regardless of what state the system is in. To do this, I'll utilize the double tap function. You'll have to click this checkbox to allow double tap, and by default, the system will grab whatever load is on the press on tab and set it to 100%. I'll want to make sure I do this for each state tab. Since this keypad configuration does not contain raise or lower buttons, you can provide the end user with a press and hold to dim function by enabling cycle dim. Keep in mind, you'll need to enable this on each state tab, and I'd recommend adding this to any other button containing dim loads on the system to keep the end user experience consistent. You obviously don't have to apply this type of logic onto every button in your system, and on some buttons it wouldn't make sense. For instance, on this exhaust fan timer button, we would want this to behave the same regardless of what time of day the button is pressed. For more information on building an exhaust fan timer, be sure to check out our video on automatic sequences. To be sure that you don't miss that video or any of our other future videos, be sure to subscribe to the Thea Enterprises YouTube channel and use the bell icon to be notified every time we upload a new video. Once again, my name is Zachary Ring. Thanks for watching.